All right, what's going on, you guys? Welcome back to Prime Logic's Math Corner. Today I'm here with you with a fascinating and interesting Math Olympiad problem from geometry. This is a real Math Olympiad problem. I'm not sure which year it was. It was in, I think it was in, I'm not sure, 1995 or something, but I will look it up. So let's talk about this problem. The question says, the triangle ABC is isosceles, meaning AB and AC. So the sides AB and AC are equal because this is an isosceles triangle. And CE is the angle bisector. So it means that it divides angle C into two equal parts. Let's say angle 1 and angle 2 are the same. Let's name the whole thing here as alpha. So angle C is alpha. And so is angle B, because this is an isosceles triangle. These two angles here on the side are the same. And the question has told us that this line, this angle bisector CE, it is perpendicular to this line BM, which is the median in this triangle. It means AM and MC are equal in length. So BM is the median of this side or triangle. AM and MC are equal, and it is formed in a way that this angle is 90 degrees. And now the question wants from us, what is the sine of C? What is the sine of this angle or this angle? Doesn't matter. What is the sine of C? So without further ado, let's jump right into this. I want you to think about it for a second, pause the video, and structure your thoughts. Okay, so let's start. Let's focus on these two triangles here, these two little red triangles. So we know that this angle is 90 degrees, so is this angle. So these two angles are 90 degrees. We know that this angle and this angle are the same because this line was the angle bisector. And we know that, okay, so this side is also shared. So both these triangles have the same side here. So based on the rules of the triangle congruence, so we know that based on this angle side angle rule, the triangle EMC is congruent to triangle EBC. Okay, so far we have found this relationship between these two triangles. Triangle EMC is congruent or the same or equal to triangle EBC. So now I have a question for you. What is the sine? What is the sine of angle A? Before that, let's find what is angle A. So if this is alpha, angle C is alpha, angle B is alpha also. So angle A is 100 degrees, 180, minus alpha plus alpha, or 2 alpha. Why? Because the sum of the inside or interior triangle angles are always 180 degrees. So alpha plus something is 180 degrees. So we know that A is 180 degrees minus 2 alpha. Then what is sine of A? So we need to find this in order to kind of find a backdoor kind of towards angle B or C, and then maybe we can find the sine of X. What is the sine of A? So this must sound familiar for you. This is a very, very, very famous yet practical rule in trigonometry. So based on the laws of trigonometry, so sine of 180 minus theta equals sine theta. So it doesn't matter whatever theta is. So 180 degrees minus theta is theta in terms of the sine. So sine A, it is sine 180 degrees minus 2 alpha. It doesn't matter, so it equals to sine 2 alpha. So sine A equals to sine 2 alpha. And we know that based on another trigonometry rule, sine 2 alpha equals 2 sine alpha cosine alpha. So this is also another important rule. So this is also sine A, right? So sine A, angle A, equals 2 sine alpha cosine alpha. Now, based on the laws of sines and based on this famous law for, let's say, this isosceles triangle and the laws of sines, we can say, so let's divide sine A over sine B, let's say. Before finding this, let me revise this one of the assumptions of this question, that AM equals MC. And because these two triangles are congruent, we can say that MC also, so let me write it down here. So we know that also MC equals this one, BC, because these two triangles are the same. And we know that AC equals to MC, or we can also say EAC equals to BC. So this is also important. Let's go back to the question. So sine A over sine B. So we have sine A here. Sine A is 2 sine alpha cosine alpha over sine B, which is sine alpha. And we know that based on the laws of sines, it equals BC over AC. So BC is the base here. AC or AB are the same thing here. So there are the sines and they are equal. So sine A over sine B equals BC over AC based on the laws of sine. So now let's write it down here. Okay, so this little thing here, BC, we know that BC over AC. So AC is 2 times bigger than BC. In other words, so AC is 1/2 of AC. So let's take a look at it here. BC is the same as MC, and MC is the half of AC. So now let's cancel these out. So we can write this one, that 2 cosine alpha equals 1 over 2. And we can say that cosine alpha equals 1 over 4, or 1/4. So we found the cosine of alpha, but what is sine of alpha? So let's write it down here. Based on this Pythagorean theorem, we know that sine squared alpha plus cosine squared alpha equals 1, right? So sine squared alpha plus, so cosine alpha, we have it. So cosine is 1 over 4, and so we should add it here. So plus cosine squared. So cosine alpha is 1 over 4. Squared is 1 over 16 equals 1. So in other words, we can say that sine squared alpha equals 1 minus 1 over 16, which is 15 over 16. Now, so you have the answer now. Sine alpha is the square root of this thing here, so it equals to square root of 15 over 4. And that's it, guys. So that's going to wrap it up for today, guys. And that was a real math Olympiad question. I hope you enjoyed our class and our walkthrough here today. And I hope you enjoyed this video. So make sure to subscribe if you haven't already, like, comment, and share. And I want you to write down your other solutions possibly. So there must be other solutions for sure. I want you to write it down in the comment sections below. And see you in our next video. So until next time, keep your logics prime. Bye from Prime Logic.